Hi and welcome back. In our first part of getting started with SOLIDWORKS CAM, we looked at how to define a machine and how to set up our part ready for adding toolpaths. In this episode, we're going to have a look at extracting machinable features to generate toolpaths, as well as manually creating them as well. So let's get started. Again, we'll go straight to the SOLIDWORKS CAM toolbar. We're going to go and press Extract Machinable Features. This will go and search your part for any features that can be found, such as a face feature, the perimeter on the outside, the pockets that have been found on the interior, a different pocket, and a series of holes there. And these all need to be machined. And we can also see that these have an abbreviation at the end of them. The face feature saying finish, the perimeter saying rough finish. And these are what we call strategies, and these are the default strategies that have been saved inside the technology database. For now, we won't open that, but we will reference it later on. What we can find then, it will allow us to click Generate Operation Plan, and this will take information that we've put into our technology database about predefined operations, and it will add them. And you can see now it's going to use a face mill, an end mill, and then a series of drills at the end. In the previous episode we assigned tools, and we can see now we've got a warning message here. If I right click and go what's wrong, we can see that I didn't add a face mill, and it's telling me there's a warning to say we've had to add one because you want to face with it. I could go and change it so it's using one of the end mills I'd picked previously, or I might think yes, I do have one of those and I can clear the warning message. But it will always stop you from making that mistake of selecting a tool you don't have. From here, let's go and generate toolpath. And this will go and set those toolpaths that we made. And you can see here, the face mill's looking great. We can move down and see what operations are done and how they're done. And we can see actually we've got one that's not calculated here. If I look at the one before it, you can see the operations being calculated. And the one after it, the finishing has been done. So there was no need for this. And if we look at this one, it was the rough rest and finish cycle. Since we don't need to rest finish, we can go and delete the toolpath. What will happen is it will go into the recycle bin. And what we can do, if needs be, is restore it at any time. Now we have our toolpaths, let's simulate them. In simulation, we can check if they're doing what we want. And you can see I've got the speed quite high to see exactly what's going off. We can see from the perimeter it's going right down to the bottom, so I may need to change that. But apart from that, the facing worked really well. And we can see the pocketing out is starting to go well. From here, you can see there's a lot of moves on the top face. This is also something we might need to have a look at because it's wasted time for us machining. It wasn't cutting anything. But as we go through the rest of the part, we can see it's roughing and finishing exactly how we want the part to be. And once this is completed, we can also go and see if there's any stock left over that we might need to machine, which is a really handy tool, especially when you've got lots of operations done for you straight away like SOLIDWORKS CAM does. And you can see here, the drilling finishes the job off. So if I move and click the button Show Difference, we can see here we have machined that part in its entirety. There's just a few tweaks that need to be done. The first for the depth on the outside, and the second to stop the spare machining on top, because that's not what we need in this application. The first one we can see is in rough mill here. There are two ways we can do this, but my preferred way is going back to the features, and we can see we have perimeter open pocket. These are editable at any time, and we can see the end condition is bottom of stock. I can simply click bottom of part and press tick, and then this will go and change the toolpath to suit. We can also go and recalculate it if we wish to as well. The other option we need to change is if I go and look down the toolpath list, we can see rough mill 4. Here we can see there's these extra passes being done on the flats at the top. By double clicking a toolpath, we can go and change any of the parameters we wish. In here we can go to roughing and we can see that machine island top is selected. I can choose to turn that off, but I could also change the first cut amount, the max cut amount, and any other parameter if I wish in here. But by simply clicking OK, you can see that goes and recalculates to give us the toolpath that we want. So now we're happy with the changes, let's go and simulate them. I could go and press simulate up at the top, and if I just want to see one operation done, I can get that as well. By right clicking and holding shift down and clicking simulate, we can see it will rebuild all of the other toolpaths done previously and give us the rough stock for them. A really handy tool if we only want to see part of the job. We can see there's been a lip left on from where we reassigned the depth on the part perimeter. If I press run now, we'll see it starts cutting around the contours of the pocket straight away, rather than finishing off the island top. And we can see there, that's got exactly what we needed. So if I press tick on that, that will give us exactly what we wanted. So to finish off this part, we might want to deburr the edges that we may have caused from machining. And this can be done and is a great way to show you how to make a manual toolpath. I'm going to right click on mill part setup 1 and pick 2.5 axis feature. In here, I can choose whichever I wanted, a pocket, a profile, and so on and so forth. But I want to get a curve feature in this instance, and we'll click auto select edges for chamfering. In here, SOLIDWORKS CAM will do the hard work for me and pick the edges, as you can see in blue, that I might want to machine. If I didn't want one, I could simply just tick it and then it would get rid of it. I can then go and pick an end condition, and we can see here the chamfer at the moment would be 10mm. I want that to be 1mm, so I'll change that as so. And from there, if I press tick, that's got me my curve feature and edge break. I can go and then make a 2.5 axis operation, which you can see it will get for me. And you can see for now, I don't have a chamfer mill to use. So I could click add new and then go and get myself a chamfer mill. So I can go and machine that. So if I get a countersink, I'll get the 5mm and click OK. It knows the feature I'm going to use. So if we press tick on here, you can see now it's got a contour mill for us. I can then go and pick the chamfer machining, whether it be the apex or indeed the outer edge. It gives you a really nice preview to which one it would be. In our case, we'd pick apex because we don't have any of the chamfers modelled on our model. So from there, if I click OK and then go and click generate toolpath, we can see there now it's going to go and grab all those for us as we want. I can then go and simulate that again to just double check I'm getting exactly what I want. And you can see there it's gone round and picked all the edges. To finish, we can get the code for the machine by hitting post process. We could call this whatever we wish, so this might be mill op1, click save, and this will go then and run through the posted output for us. This goes and generates all the code that we might want in a really handy way. We can also go and set that the software will open the NC editor so we can preview the toolpath that's going to be used on the machine. And by clicking OK, this loads up and you can see we get shown exactly what we want. We can choose what type of code it is, in this case ISO milling, and it will give us color coding depending if we're rapiding, feeding in, or if it's a tool change. We can also go to backplot and backplot the window, and we can see there it gives us a true representation of the G code of what we're going to run. And this also can be simulated as well to check that SOLIDWORKS CAM is tying up with the code that's been outputted as well. It's really handy and really useful to do a double check of all your machined components. I hope this has been useful for you, and thank you for watching.